It's recording. Thanks. Oh, yeah.
Fix that. Good afternoon, class of grade 8s of Acton Elementary. Today we're going to be talking to you guys about mechanics principles in dams. We're going to discuss what are dams used for in real life. We're going to discuss some physical properties of dams, and then we're going to do some activities to make sure you guys understand those concepts really well. Afterwards, we're going to do a Kahoot to summarize everything we learned, and it's going to be a great time. The first thing that we think about when we think of dams are obviously beavers. So you might notice that there are a couple of beavers in this presentation. So try and pay attention to where those are, as it may be useful later, just as a little hint. So with that being said, let's get into our presentation about dams.
Okay, what are dams? There are many definitions for what a dam is. Oxford Dictionary describes a dam as a barrier constructed to hold back water and raise its level, forming a reservoir used to generate electricity or as a water supply. In our presentation today, we will be discussing and doing activities using the physical principles of a dam.
There are many different environmental impacts of dams, some positives while other negatives. Let's start with the pros of dams. They decrease the pollution effect by lowering the pollution carried by rivers. They are a powerful source of renewable energy that can produce electrical energy in an environmentally friendly way. And finally, they help in increasing agriculture and plantation. Now, as for the cons, they often act as a barrier to the pathways of fish and limit them from migrating and reproducing. As a result, the aquatic wildlife is put in risk. They also lead to the flooding of the surrounding environment, which the water spills into, which is dangerous to the animals and inhabitants living in these areas. Finally, the reservoir behind rivers often emits a high percentage of greenhouse gases, which are a main cause of global warming.
Why are dams important for society? Dams are essential structures that allow us to collect water reservoir for future use. These uses include collecting water for drinking, the production of renewable energy, including hydroelectric power to generate electricity, protection from floods, and an increased production of crops and growing landscapes. These are very important things for society, so it represents the dam's importance to the world.
Now, you might be wondering, what is mechanics? Mechanics is the study of energy and forces as well as their effect on object. Mechanics describes Newton's laws and their consequences. Does anyone here know any of Newton's laws? Well, Newton's first law is that an object in motion or at rest will stay in motion or at rest unless acted upon by an external and unbalanced force. Newton's second law states that an external and unbalanced force acting on an object will result in acceleration. And finally, Newton's third law states that for every reaction force, there's an equal and opposite reaction. In other words, mechanics is the study of how things move.
Okay, what are forces and pressures? Forces are mathematically defined as mass times acceleration. An example of this is when a ball with a larger mass will hit the ground with a larger force than a ball with a smaller mass. Now moving on to pressure. Pressure is mathematically defined as force divided by area. An example of this is as the area of the object decreases, which is the size, then the force will become more distributed, or as the area of the object increases, the force will become more distributed, causing a low pressure.
There are many different forces that act on dams, including the water pressure, also known as hydrostatic pressure, since dams are built to hold large amounts of water that they should withstand, the uplift pressure, which is basically the movement of the water under the dam exerting a force upwards, the earth pressure, which includes things like earthquakes, and the wave pressure, which is generated on the surface of the water due to the wind, in addition to the weight of the dam itself.
Yeah, hydrostatic loads. What is a hydrostatic load? Hydrostatic loads are pressures that result from the weight of the water acting on a surface. They depend on three main factors. First is weight and density of water. The second is the acceleration of water due to gravity. And the third is the volume and area of the surface. When it comes to dams, they have to carry the perpendicular hydrostatic load pushing towards the sides of the dams from this water surface. This is demonstrated in this picture here. And as the depth of the water goes down, you see that the arrows become much longer, indicating a larger force or pressure.
Now, it's time to do our first activity. The objective of this activity is to observe water pressure at different depths. What you will need for this activity is a plastic cup, tape, water, and paper towels. I'll quickly go over the procedure, then give you time to do this activity in groups of 3 or 4. First, you will need to gather your materials and grab a plastic bottle. Poke 2 holes along the same side, one at the top and one at the bottom, then cover each hole with tape. Afterwards, fill the cup with water and remove the tapes. I want you all to observe the difference in the pressure of the water and discuss this in your groups. You can pause the video to do so.
Okay. Relationship between water pressure and water depth. Water pressure towards the bottom of the bottle is greater than the water pressure towards the top of the bottle. Why is that? There's a very simple explanation between water pressure and water depth. That is the weight of the water. The water at the bottom is under a lot more weight because there's so much water above it. That creates a greater pressure. A real life example of this is when you go diving, scuba diving. Your ears start to pop and your head starts to hurt because the pressure of the water just becomes too great and you have to resurface.
Okay, so dam thickness explained. In your previous activity, you should have learned about the relationship that exists between water pressure and water depth. As you can see on the photo on the right, dams are constructed so that their thickness increases from top to bottom. This allows the dam to better resist the larger hydrostatic loads and pressures exerted from the base of the water. So dams in nature. The most obvious example of dams in nature are, of course, beaver dams. Beavers build their dams to restrict the flow of water around their environment, allowing for a safer habitat for the beaver as well as for other animals in the ecosystem. Although humans and beavers build their dams for very different reasons, they share many of the same structural features. So in this photo here are human dams and beaver dams. What similarities can you see between the two? That's right, they're both curved. So some more similarities between human and beaver dams are that human dams are made out of steel and concrete and are generally used to generate electricity. Beaver dams, on the other hand, are made of sticks and mud and are used to produce a protective habitat. Both are curved in shape and both use materials to resist specific forces. We'll go over those in more detail later.
Moving on to our next activity. For this one, you're going to need a paper, eraser, pencil, and you're going to need to find a friend. Step 1, you're going to get one of your friends to hold out the piece of paper in front of you in a horizontal position. Make sure to hold it tightly. Then you're going to get someone to place an eraser on top of the paper and give it a gentle push. See what happens. Next, you're going to swap out the eraser for a pencil and you're going to push at the paper with the tip of your pencil and observe what happens. You're going to repeat these 2 steps, but this time you're going to curve the paper one way. So you're going to curve it in an upwards position and try poking it with the eraser and the pencil, and then curve it the other way and try poking at it. Try and notice what happens differently in all these situations, and good luck. So after you've done the experiment, what did you notice about the results when the page was flat versus when the page was curved? What did you notice about the amount of pressure you were able to exert on the paper? Try and think about why these properties change what happens as you press each object into the paper. Next activity, dam structures. For this one, you're going to need your cardboard box, marbles, a ruler, scissors, and cardboard paper. This time, you're going to take your cardboard paper and cut it to the size that's the width of your cardboard box and place it horizontally in the box. Now think, what do you think this piece of cardboard paper represents? That's right, it's a dam. So now that, with the knowledge that it's a dam, your marbles are going to act as your fluid. So gently pour the marbles into the box with your dam until the dam fails. At this point, you're going to take your ruler and measure the height at which you're able to get the marbles to. Record this value for later. Next, you're going to cut a new piece of cardboard paper, but this time you're going to make it slightly wider than the dam. So when you put it in, it has to curve in a concave, curved arch shape. Now you're going to do the same thing by pouring your marbles into the box until your dam fails. Once it fails, take the height of the new marble height once the dam wall collapses. Compare these 2 values. What did you notice? Was the height of the marbles, were you able to get a higher height of marbles with a curved dam, or were you able to get a higher height with the flat dam? Try and think about why your results happened.
So forces and arches. In your activities, you may have noticed that a curved structure is able to support a larger load than a flat structure. This structural feature is called an arch. Arches gain their strength directly from their shape. Downward forces from the top of the arch are transferred along the length of the curve, allowing it to go all the way to the base of the structure. This transfer of forces allows the arch to support much larger forces and loads than a conventional flat surface. So in this photo of a dam here, you should be able to see the way the components of an arch work together to produce a system that can carry the load and pressure exerted on it from the water surrounding it. So here are a few examples of dams constructed by people. Next is compressive and tensile forces. Compressive forces resist forces that act in a manner that crush or squeeze elements of the structure. Tensile forces act in a way that stretch out elements of the structure. So compressive and tensile resistant materials. In compressive resistant materials, small stones fill up the little gaps in the concrete, providing a more robust and compact structure. As a result, compressive resistant materials, such as concrete and ceramics, are used to support and resist compressive forces on structures. In contrast, tensile resistant materials need to be able to be stretched, meaning that more ductile materials are better suited for resisting tensile loads. Fiberglass, epoxy, and steel are better at resisting tensile forces because they are more malleable and less brittle than concrete and ceramics. When these materials are combined, their attributes allow for more secure and well-built structures. So here are some more examples of the combined materials. We can't go too far in depth into this subject, so I've attached a QR code into this presentation. You can scan it to see a video that describes this concept a little bit better.
Okay. Fun facts about dams. Beavers are the only wild animal that builds dams. Dams provide 1/6 of the world's energy, and dams reduce the risk of floods and droughts. Damn, that's so cool.
Thanks for watching your presentation today. Now we're going to move on to the Kahoot section, which we're going to test what we just discussed, which includes content from the slideshow and from the activities you just did. So good luck. You can pause the video now and open up the Kahoot and get ready to play.
Stop the recording now.
Yeah. Good work, guys. Good work.